A quiet panic is sweeping through the boardrooms of Silicon Valley. Startups are building mind-blowing artificial intelligence, only to realize the server bills will bankrupt them in months. To survive, engineers are quietly applying a mathematical trick that slashes their compute costs by 75% overnight. But they are not telling you what they had to sacrifice to get that discount. We are told that the models we use every day are getting smarter, faster, and more efficient. But behind the scenes, the AI industry is facing a brutal reality. Running uncompressed models at scale is economically unsustainable. To survive, the industry has embraced an invisible compromise called quantization. It is the biggest open secret in tech, and it is quietly changing the way machines think. To understand how we got here, we have to look at the physical real estate of the AI age, video random access memory, or VRM. An artificial intelligence model does not think like a human. It is a massive file containing billions of numbers called weights. When you ask an AI a question, every single one of those weights must be loaded into the ultra-fast memory of a specialized graphics chip. By default, these weights are stored as 16-bit floating-point decimals. In this high-resolution state, a 70 billion parameter model requires about 140 gigabytes of premium memory just to run. That requires multiple high-end enterprise chips, costing tens of thousands of dollars. Quantization is the process of downsizing these numbers. Instead of storing a weight as a highly precise 16-bit decimal, engineers round it off to an 8-bit or even a 4-bit integer. Instantly, the memory footprint shrinks. A model that once required a specialized server cluster can now fit on a consumer-grade graphics card. But mathematics does not offer free lunches. Imagine trying to map the location of a buried treasure. If you have precise global positioning coordinates down to 8 decimal places, you can walk right to the exact square inch where it lies. This is your uncompressed, high-precision model. Now, imagine a rule change. You are no longer allowed to use decimals. You must round every coordinate to the nearest city block. Suddenly, you cannot pinpoint the exact spot anymore. You can only point to the general neighborhood. This is exactly what we do when we quantize an AI. We force a hyper-detailed mathematical blueprint onto a coarse grid. Most of the time, the model can still guess the correct word or write a decent email. But the subtle, critical nuances of its reasoning are rounded away. The smooth curves of its intelligence are forced into rigid, jagged blocks. For a long time, computer scientists assumed that quantization was harmless. They believed that because an AI has billions of weights, rounding them off would cause minor errors that would simply cancel each other out. But they were wrong. In 2022, researchers discovered a bizarre structural trait inside large language models: the existence of outlier features. Within these massive networks, a tiny fraction of the mathematical coordinates hold an incredibly high amount of influence over the entire system's reasoning. They are like the master controls of the machine's brain. If you apply standard quantization to these outliers, their values are flattened, and the model's performance collapses entirely. To keep the AI from completely losing its mind, modern compression techniques must keep these critical outlier coordinates in high precision while aggressively squeezing everything else. It is a desperate balancing act, and even when done perfectly, it leaves the system highly fragile. The most dangerous thing about a compressed AI is that it does not fail loudly. It does not crash, freeze, or display an error message. It suffers from silent degradation. If you ask a quantized model to write a basic marketing email or summarize a news article, it will perform beautifully. This is because language generation is highly forgiving. But when you push the model into complex logical reasoning, multi-step math, or advanced software engineering, the rounding errors begin to compound. Like a long game of telephone, a tiny error in the first step of reasoning alters the context of the second step. By the 10th step, the AI has drifted far off course. It delivers an answer with absolute confidence, but the underlying logic is broken. For enterprises deploying these models to automate financial decisions or write code, this silent drift is a ticking time bomb. While silent logical errors are a massive headache for developers, academic research has revealed an even more pressing threat. Quantization systematically erodes an AI's safety guardrails. When tech companies train a model, they spend millions of dollars on alignment, teaching the AI to reject requests for harmful instructions, dangerous code, or hate speech. These ethical boundaries are incredibly complex and nuanced. But research shows that when a model is compressed from 16 bits down to 4 bits, these delicate guardrails are often the first things to break. Because safety alignment relies on subtle linguistic boundaries, reducing mathematical precision makes it dramatically easier to bypass these rules. A jailbreak prompt that would be instantly blocked by a high-precision cloud model can sail straight through a compressed version of that exact same model. The protective walls have literally been rounded down. This dynamic explains the current paradox of the local AI movement. Across the world, millions of enthusiasts and developers are celebrating their ability to run massive 70 billion parameter models directly on their personal laptops. They download compressed files labeled Q4 or Q8, marveling at how fast and cheap they are to run. But this has created a dangerous illusion of capability. Users run standard benchmarks and see that the compressed models score nearly as high as the originals. What they do not realize is that standard benchmarks are often too simple to expose the subtle cracks in reasoning. In the real world, running a highly compressed model is like driving a high-performance sports car with cheap, worn-down tires. It feels fast on a straight line, but the moment you try to take a sharp corner at high speed, you will lose control. As we build the infrastructure of an automated world, we are making a monumental trade-off. To make AI economically viable, we are choosing to run our society on quantized systems. We are trading precision for affordability, safety for speed, and reliability for profit margins. There is nothing inherently wrong with compression. It is the very technology that made digital streaming and mobile computing possible. But unlike compressed video, where a loss in quality only means a slightly blurrier image, compressed intelligence means a loss in truth, logic, and safety. If we do not begin to pay closer attention to the mathematical compromises happening behind closed doors, we may soon find that the automated systems we rely on are far more fragile than we ever imagined.